Hey everyone, Ms. Laux here. Today we are going to do section 3.5 of Foundations in Pre-Calc 10, polynomials of the form x squared plus bx plus c. Now what that means is that the coefficient in here is a 1, and that number, the b and the c, those both represent numbers. The x, of course, is the variable. So b and c are numbers, and they can be any number. But the coefficient for the x squared term has to be 1. Okay? So yesterday, or last class, you were doing using algebra tiles to multiply polynomials. And here's an example. We have on this side, we have c plus 3. And on this side, we have c plus 5. And just to remind you how this works, c times c is c squared, and 1 times c is c, and 1 times c is c, and 1 times c is c, and 1 times 1 is 1. So we have c squared, and 1, 2, 3, 4, 5, 6, 7, 8 c. That's where the 8c comes from. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So plus 15 ones. So that's how the algebra tiles work. So you could also use algebra tiles to multiply, you can also use an area model to multiply two binomials. So, for example, if we had h plus 11 times h plus 5, we could do it with an area model. So that just means we take a rectangle, and it doesn't matter what size or shape it is. I try and keep my h looking the same on both sides, but it really doesn't matter. So this side has dimensions h plus 11, and I'm saying this part of it here is h, and this part of it is 11. Okay, so there's our dimensions. This part is h, and this part is 5. So this side is h plus 5. So h times h is h squared. H times 11 is 11h. H times 5 is 5h. And 11 times 5 is 55. So what we have is h plus 11 times h plus 5 equals, we have an h squared, and we have 11h, and we have 5h, and we have 55. And then when we combine like terms, this simplifies to h squared plus 16h plus 55. So we get that h plus 11 times h plus 5 equals h squared plus 16h plus 55. All right. Now, these techniques work well when all the terms are positive, but you can't use an area diagram if there's a negative term, because what's a negative distance? And we can't show what, for example, h minus 2 equals unless we actually know what h is. But we can use a rectangle diagram, which is, it says here it's virtually the same thing. It's actually exactly the same thing. In practice, it's just we're not representing area, so we're not going to call it an area diagram. We're calling it a rectangle diagram. So let's do a rectangle diagram where we've got some negatives involved. So multiplying two binomials using a rectangle diagram. So let's draw my rectangle. This is c plus 3, and this is c plus negative 7, right? That's what c minus 7 means. So c times c is c squared. 3 times c is 3c. c times negative 7 is negative 7c. And 3 times negative 7 is negative 21. So we get c plus 3 times c minus 7 equals c squared plus 3c minus 7c. Now we could say plus negative 7c. That's the same thing. minus 21, which simplifies to c squared minus 4c minus 21. Now, I'm going to tell you right now that if you're having trouble combining like terms, or you're having trouble with me writing minus 7c instead of plus negative 7c, you really need to get some practice work from last year, because you are very quickly going to get lost, and I don't want that to happen. So come let me know that this is a struggle for you, and I'll find you some practice work to catch up. Okay? So that's one way of doing it. The other one is using the distributive FOIL property, which we also call foiling it, and you may or may not have seen this last year. FOIL stands, let me talk about the distributive property first. So the distributive property, this means that every term in the first factor is multiplied by every term in the second factor. Okay? And the way we do that, we go first. So we go first times first. So this is c times c, which equals c squared. Now, I'm writing it out in painful detail this time, and I would like you to write it out in painful detail this time, just so you have a record of where these numbers come from. After this one time, I won't expect you to write it all out like this, but please do for the sake of completeness in your notes. Okay, so that was the first, and then we go outer. So we go from the very first one, to the very last one. And this is c times negative 7. You need to make sure you take that negative sign with you. So this is negative 7c. And then inner, so this is 3 times c, which is 3c. And last, so the last of the first set and the last of the second factor. So that's 3 times negative 7, which is negative 21. So we get c plus 3 times c minus 7 equals c squared minus 7c plus 3c minus 21, which looks kind of familiar, doesn't it? And then c squared minus 4c minus 21. Okay? And we need to check this, but I don't think I have room. I can fit it in there. Okay. So, check. And we're going to check it by testing x equals 1. Because whatever value, the idea is that these two are equivalent, right? So if we plug in, well, not x, actually, I guess it would be c. I'll fix that. That if c equals 1 and we put that in the first set and we get a value for that, and then we put c equals 1 in the answer, the multiplied out that we got, or expanded, then that must be right. You can use any number. Don't use 0, because 0 hides a multitude of sins. Lots of errors don't show up if you use 0. And don't use negative 1, because it just makes life complicated. 1 is easy. 1 is fast. So, so c squared, I'm going to write it all out. C squared minus 4c minus 21. That is 1 squared minus 4 times 1 minus 21, which is 1 minus 4 minus 21, which is negative 24. Now again, you wouldn't write it out in that much detail, but I want you to see where the numbers come from. Okay. And then we would also go over here, c plus 3 times c minus 7. So 1 plus 3 and 1 minus 7, so 1 plus 3 is 4, and 1 minus 7 is negative 6, which, haha, equals minus 24. So, yay, they're the same. So our answer is right. Now, we could have tried any number. You could use 14.7 if you want. I wouldn't recommend it because it takes a lot more time. 1 is quick and easy. Okay, next example. And this time I will show you, well, when we FOIL it, I'll show you the writing that I would actually do for something like this. Okay, but let's do the rectangle diagram again. So I need to draw a rectangle. And it doesn't matter where I split it because this is just a representation, right? So this is 5, and this is negative s, and this is 9 and negative s. So 9 times 5 is 45. 9 times negative s is negative 9s. 5 times negative s is negative 5s. And negative s times negative s is s squared. So we have 45 minus 9s minus 5s plus s squared. Now the convention is that we write from the biggest exponent to the smallest exponent. So the convention is we would write this as s squared minus 14s, because I'm combining these terms together, plus 45. So there's my answer. Okay. Now when I FOIL it, it's going to be 5 minus s times 9 minus s. And first, outer, inner, last. We usually draw the lines like that so they're not quite so confusing. And 9 times 5 is 45. 5 times minus s is minus 5s. This is minus 9s plus s squared. And then I'm going to rearrange it again just like I did before. So minus 14s plus 45. And ta-da, we get the same answer. Okay, and then to check it, I'm going to do that in red this time. I'm going to go 1 minus 14 plus 45, which equals 32. And then I would go 5 minus 1 is 4, 9 minus 1 is 8, which equals 32. So there's my check. So that's the writing I would actually do for my check. I would write it down so that I know I've done it. And then it's a really good idea to put a box around your answer because we have writing after our answer, and you don't want the person marking your test to have to hunt for your answer. Okay. All right. We are going to stop the video there because it's your turn. So you go ahead and do the next 2 examples. Do C and D, and then come back and check your answers. Okay, there are your answers for C and D. If you got them right, you can skip ahead, and if you didn't, I will draw them out for you. Okay, so for the rectangle diagram, we have x minus 4 and x plus 2, so x times x is x squared. This is minus 4 times x, which is minus 4x. This is 2x. This is minus 8. So we have x squared minus 4x plus 2x minus 8 equals x squared minus 2x minus 8. To FOIL it, we have first, which is x squared. Outer is 2x. Inner is minus 4x. Last is minus 8. So x squared plus 2x minus 4x minus 8 equals x squared minus 2x minus 8. And yeah, we did them in a little bit of a different order than we did at the top of the page, but get the same answer, so it doesn't matter at all. Okay, next one. Rectangle diagram. (8 minus b 3 minus b. 3 times 8 is 24, minus 3b, minus 8b, and b squared is 24 minus 3b minus 8b minus b, plus b squared, which cleans up to b squared minus 11b plus 24. And if we FOIL it, we have 8 minus b times 3 minus b, first, outer, inner, last, 24 minus 8b minus 3b plus b squared, which is b squared minus 11b plus 24. And to check this is with x equals 1. So 1 squared is 1, minus 11 times 1 is 11, plus 24, and that equals 14. And then if I'm using the ones up here, 8 minus 1 is 7, and 3 minus 1 is 2, which equals 14. So happy day, our answer is correct. And let's put a box around it. Okay. Hopefully you got that. Moving on. Okay, now we've come to the fun stuff. We are factoring trinomials. And we can do this using algebra tiles, so let's start there. So when we do this with algebra tiles, the first thing we're going to do is start with the v squared. So I'm going to draw my v squared. And I'm going to draw this as a square. Okay, so that's my v squared. And then I'm going to arrange the ones in a triangle, and I need to have 12 ones. And I need to put them in a triangle, so I'm going to put that in a triangle that is 3 by 4. And these are all supposed to be little squares, right? Okay, so I have 12 of those. And now I need to put my V's in, and I need to have 8 of those. So I'm going to actually do these in a different color just so you can see what I'm doing. So there's 1, 2, 3, 4, 5, 6, 7, and I have one more. Doesn't fit. I have to try again. Oops, try again. Okay, so this time I'm going to put my v squared in again. And I need to arrange my 12 ones in a different shape, so this time I'm going to go, 2 by 6. 2 by 6 will give me 12, so let's try that. I love how this takes a straight line and decides that I wanted a curve there. Okay, so we have 6 times 2 is 12, and let's put some v's in now. So 1, 2, 3, 4, 5, 6, 7, 8. That worked. Okay, and then I'm going to go to my black pen, and I do this and this, and I have a V, and then I have 1, 2, 3, 4, 5, 6 ones, so this is V plus 6, and this side is a V plus 2. So when I factor this, this equals V plus 6 times V plus 2. Okay? So that's how you factor it using algebra tiles. You just have to make it work. You just have to rearrange it until you have enough space for all of your pieces to fit in. Okay, now, that gets tedious, and especially with bigger numbers, yeah, you don't want to do that. So notice the pattern, okay? So we have V squared plus 8V plus 12 equals V plus 6 times V plus 2. notice that $12 equals 6 times 2. So this is a product. And I'm going to do this in a different color. 8 equals 6 plus 2. So this is a sum of those same numbers. The same numbers. Okay? And we can use this to factor algebraically. And notice that, remember that your answer will have the form of a variable plus an integer times bracket a variable plus an integer. That's what we have up here. We have a variable plus an integer and a variable plus an integer. Now sometimes the integer is negative, but we will come to that. So I have written out here to do it algebraically. I have these steps. They're kind of scary. I mean, it looks complicated, but it's just, if you have the steps in front of you, it makes it really easy. So I want you to try it with the steps a couple of times. So list the product and the sum. So this is the product and this is the sum. Now, if you forget for some reason, do it the other way. Make up a binomial. X plus 1 times x plus 2 is really easy. FOIL it out. Figure out which one is the product and which is the sum, and then you can work backwards. Okay, it's always good to have a way to figure something out in case you forget. Okay, but we don't have to do that today, so we know the product is 12 and the sum is 8. And then what I want to do is list all the ways that I can factor the product. So factoring 12 is 1 times 12, 2 times 6, 3 times 4. Is that it? Not really, because I could also go minus 1 times minus 12, minus 2 times minus 6, and minus 3 times minus 4. That also gives me the product of 12. What I need to find, though, is the sum of 8, and only one of these will ever work. And this time, it's this. And then what I do, so I've done, now I've listed my product and sum, I listed all the ways, I figured out which combination of factors can be added to find the correct sum, which is 8. And then I insert the factors into my answer. So my answer is going to go v plus something times v plus something, and it's going to be 2 and 6. How easy was that? The 2 goes here, and the 6 goes here, and of course it doesn't matter whether I go 2 and 6 or 6 and 2, I get the same answer. Okay, and then always, 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 always check your answer. Always, always. Okay, it takes hardly any time at all, and you will make mistakes, and this is how you will catch them. So v squared plus 6 squared, oops, plus 6v, sorry, plus 2v plus 12 equals v squared plus 8v plus 12, which, yes, is what we started with. And then it's really important that you come back and you put a box around your answer so that it can be found. Because it's kind of in the middle of everything, right? And this part down here is not your answer. That's what you started with. Okay? Your turn. So go ahead, do these next two questions. Next one question, just do this one. And then come back and check. Okay, the answer to this is d plus 3 times d plus 4. And of course, if you got that right, you can skip ahead. But I will show the answers for anybody who needs a little bit of help. So here's my d squared tile. And I'm going to do my ones is going to be 12 that goes 3 by 4 like this. And then I get 1, 2, 3 D's up here, and 1, 2, 3, 4 D's down here. So this is D plus 3, and this is d plus 4. That's how I get my d plus 3 times d times 4. Let's do it algebraically, because really the algebraically is more important, although you do need to do both. So product equals 12, sum equals 7. So to get 12, we can have 1, 12, we can have 2, 6, we can have 3, 4, and that's the answer that we're needing here. So d plus 3, d plus 4, and then seriously, I FOIL it every time. I might not draw the lines, but I always check. D squared plus 4d plus 3d plus 12 is d squared plus 7d plus 12, which, hooray, is what we started with. Let's put the box so that I can find the answer. Okay, next, these techniques actually both work. These examples we did always had positive terms. They do both work with negative terms as well. The algebraic works great with negative terms. The algebra tiles is a little awkward with negative terms. I'm just going to do an example for you. I'm not actually going to ask you to do this, but I just want to show you how it works. So I'm still going to start with my x squared tile. And I need, so there's my x squared, and I need 8 minus 1 tiles. So I'm going to put that down here. Oh, I'm going to do those in a different color because they're negatives. Let's do those in black. Because I can't color them in on the screen, that's not going to work. So there's my minus 8 tiles. And I can tell by looking at this that I only have two negative x tiles. I can't add that in any way that's going to make a rectangle. Okay, so I need to add what we call 0 pairs. Because I can see that I'm going to need 1, 2, 3, 4, 5, 6 more tiles, and I only have 2, so I need to add 4. So if I add, oops, oh, okay, I can add, that's a negative x and a positive x, because minus x plus x equals 0. So if I add that, I haven't actually added anything, have I? So now if I do that twice, plus I had 2 more minus x tiles, right? That I had from up here that I haven't used yet. Now I can see that I can put in 1, 2, 3, 4. These are all minus x tiles. And I can put in a positive x tile and a positive x tile there. That makes my rectangle. Now, you need to be careful with this because, oh, I don't really want to use that color, do I? Let's use red. Okay, on this side, I have a positive x and a positive 1 and a positive 1, so this is x plus 2. And on this side, I have an x, and I have 1, 2, 3, 4 negative, so this is x minus 4. Okay, then you need to check that x times x is x squared, and negative 1 times x is negative x, right? And this is the negative here. That works all the way across. And then 1 times x is positive x, and negative 1 times 1 is negative 1. So that all worked, okay? So our answer is x plus 2 times x minus 4. Okay, so you can factor it using algebra tiles. But I'm not going to ask you to do that, at least not today. So let's go to the next section, which is factoring it algebraically. Okay, let's factor this algebraically. So our product is -8, and our sum is -2. So how can we make -8? We can have -1 times 8. We can have -2 times 4. Or we can do 1 times -8 or 2 times -4, and that's it. Now, I always write it this way because it just, patterns are good. Okay, and which one is going to work? It's going to be this one, because if I add those together, I get -2. So my answer is going to be a plus 2 times a minus 4. Okay. It just occurred to me that I didn't actually address why is it we list the products and not the sums. And the reason for that is there are literally an infinite number of numbers that you can add together to get a sum of -2. You could go 2 million plus -2 million and 2. I mean, it's ridiculous, right? Whereas the product, there is a finite number of integer answers that are going to give you a product of -8 or any other number that we are dealing with here. So that's why. Okay, and then I'm going to FOIL this to check that my answer is correct. A squared minus 4a plus 2a minus 8 equals a squared minus 2a minus 8, which is what I started with. So yay. Okay, factor this one. A squared plus 7a minus 18, product equals 18. Sum minus 18, sorry. Sum is 7. Now, just a couple of tips. If the product is positive, your two factors are both going to be either both negative or both positive. If your product is negative, one is going to be positive and one is going to be negative. That's always true. Okay, so how do we make 18? So we can have -1 and 18. We can have -2 and 9. Oh, and that's as far as I needed to go this time. That's going to work. So a minus 2, a plus 9, and then let's check that. That's a squared plus 9a minus 2a minus 18, a squared plus 7a minus 18. Check. Box my answer. And I didn't box my answer up here. My bad. All right, your turn. Go ahead and do the next two questions and then come back and check your answers. Starting in 3, 2. So this one equals x minus 1 times x minus 7. And this is going to be z minus 5 times z minus 7. Okay? So you can skip ahead or you can watch. Product is positive 7, sum equals -8. So the only ways you can make 7 is 1 and 7 or -1 and -7. And because the sum is -8, we need to do this. So x minus 1 times x minus 7. And I'm not going to bother checking it, but I do strongly recommend that you check it. I actually have checked it, so I know that's right, but I'm not going to write it out. So product is 35, sum is -12. So I actually know right away they both need to be negative, so I'm just going to, well, I'm going to write them as positives because that's easier, but I know that I'm going to use the negative version. So what I'm actually going to do is this. This can be 1 times 35. This can be 2 times, oh, nothing works. This can be 3 times, nothing works. This can be 4 times, nothing works. Or 5 times 7, but it's actually going to be -5 minus 7. Okay, so I get x minus 5, and x minus 7. There we go. Okay, we're almost done. We are just needed to do factoring a trinomial written in ascending order. And it's the same thing, you just end up with your answer in a different shape. You get an integer first and then the variable instead of the variable and then the integer. But the product is always just this number that's by itself, so we call that the constant. And the sum is the one that is with the single letter of the variable, not the squared term. Okay, so product equals negative 30, sum equals 7. So negative 1, 30, nope, negative 2, 15, nope, negative 3, 10. Oh yeah, that'll work. So I'm going to put my number first. So negative 3 plus m and 10 plus m. And this one I'm definitely going to FOIL out because this one is a little weird. So I get negative 30 minus 3m plus 10m plus m squared equals minus 30 plus 7m plus m squared, which, hooray, is what we started with. Yay! There we go. Okay, I will do one more example, and then you have 2 to do. Oh, no, that's it. It's your turn. Oh, but I lied. There's one more thing to do after this. So you go ahead and do this. Come on back and check your answer.
Well, I somehow missed recording doing this question, but here is the answer and the work. Okay, so I'm going to just move on to the next concept.
Okay, now we need to combine what we did last day with what we're doing today, which is we need to factor out a GUKF. So the GUKF in this case is negative 5. So we're going to factor that out. So this becomes negative 5 times h squared plus 28, plus 4h. I was thinking I need to make sure to tell you to watch that plus and minus because that's where the mistakes happen, and then I write the wrong number down. Minus 12. Okay. And then I just need to factor this part. Okay. So my product is negative 12, and my sum is 4. So I can do minus 1 and 12. Nope. Negative 2 and 6. Whoops. I think it's time for me to go to bed. And 6. That works, right? So we still have the negative 5, and now we have h minus 2 and h plus 6. And I'm going to check this one using subbing in a value for x. So x equals 1 is what I'm going to do. So I have minus 5 times 1 minus 2 is negative 1, and 1 plus 6 is 7, so my answer is 35. And if I come up to the beginning, this is going to be minus 5 minus 20 plus 60, which does also equal 35, so my answer is right, and I will put a box around my fully factored answer here. Okay, your turn. Go do this last question, and then come on back and check your answer. The answer to this is negative 4 times t minus 4 times t plus 8. And the way we do that is we have the GUKF equals negative 4, so I have to factor that out. This is negative 4 times t squared plus 4t minus 32. And then I need to factor just what's inside the brackets. So my product is negative 32, my sum is 4, So I can have negative 1, 32, negative 2, 16, negative 3 doesn't work, negative 4, and 8. That works, negative 4 and 8. So I still have my negative 4, and I have t minus 4 and t plus 8. Okay, there you go. See you in class.